In this video, I'm going to show you how to evaluate these 5 integrals. Let's get started. First, let's review the tools that we need to evaluate those integrals. So we have here integral formulas yielding inverse trigonometric functions. So we have integral of du over square root of 1 minus u squared is equal to arcsine u plus c. Integral of du over 1 plus u squared, it is equal to tangent inverse u plus c. And then integral of du over absolute value of u times square root of u squared minus 1 is equal to secant squared du plus c. Let us now evaluate those integrals. First, let's integrate dx over 1 plus 9x squared. It seems that our integral is in the form integral of du over 1 plus u squared. So therefore, for this integral, we're thinking of using the formula integral of du over 1 plus u squared, which is equal to tangent inverse u plus c. Now, what is u in this case? If we're going to write our integral in this form, then this means we have to write this one here as integral of dx over 1 plus u squared. And 9x squared can be written as something squared, so that is a 3x quantity squared. So in this case, if we want to write our integral in this form, then we have to set the 3x to be our u. So we let u to be equal to 3x. And if u is equal to 3x, then our du is just equal to 3 dx. So therefore, we can now write our integral as 1/3 integral of 3 dx over 1 plus 3x quantity squared. And the numerator is just equal to 1/3 integral of du over 1 plus u squared. And using this formula here, we get 1/3 tangent inverse of u plus c. And putting back the u in terms of x, we get 1/3 tangent inverse of 3x plus c. Next integral. So let's evaluate the integral of tangent x secant squared x over square root of 1 minus tangent raised to 4 of x dx. If we look at our integrand, it contains a denominator which is in the form square root of 1 minus square of a function. It is a square of tangent squared x. So for this integral, we might use the formula for inverse sine, which is integral of du over square root of 1 minus u squared equal to sine inverse of u plus c. And if we want to use this formula, then our u should be equal to tangent squared x, so that our radicand is in the form 1 minus u squared, because the square of this is equal to tangent raised to 4 of x. So, but if u is equal to tangent squared x, then our du is equal to, again, chain rule. You bring down the power, okay? You subtract 1 from the power, so that is tangent x, times the derivative of the base, because this one, it's in the form tangent x quantity squared. So we apply here extended power rule. So you bring down this power, you subtract 1 from the power, so this becomes 1, and then multiply it by the derivative of the base, which is derivative of tangent x, that is equal to secant square x. And then, of course, times dx, which is just a constant multiple of this numerator here, tangent x secant squared x dx. Therefore, we can write our integral as this part here can be written as du over 2, because just divide both sides by 2 here, and you'll get an expression for tangent x secant squared x dx. So that is equal to du over 2. Or we may write it also as 1/2 integral of 2 tangent x secant squared x dx over the square root of 1 minus the square of tangent squared x. And now we can replace the numerator already by du, and then the denominator by square root of 1 minus u squared. And using this integration formula, we get 1/2 sine inverse of u, and then plus c. And then putting back the u in terms of x, we get 1/2 sine inverse of tangent squared x plus c. Next problem. Let's evaluate this definite integral here, integral of dx over x squared of x plus squared of x from 1 to 3. So what formula do we need to evaluate this integral? If we look at this denominator here, okay, there is a common factor which is equal to square root of x. So let's factor that out first. So we have here integral from 1 to 3 dx over square root of x, and then you have here x and then plus 1. Now, what is the form of this integral? So clearly, we don't need to use the integral formulas for secant inverse u and sine inverse u, because you have the denominator square root 1 minus u squared, or square root of u squared minus 1. And this is just a sum. So to evaluate this integral, we may try to use the formula for tangent inverse, which is integral of du over 1 plus u squared, because this part here can be written in that form, 1 plus u squared, where u is equal to square root of x. So this is just equal to tangent inverse u plus c. So if we write this in that form, 1 plus u squared, then we'll get here integral from 1 to 3 of dx over square root of x times the square of square root of x, and then plus 1. So now it is already in this form where u is equal to square root of x. So when we let u to be equal to square root of x, then our du is equal to 1/2, just ordinary power rule. So 1/2 x raised to negative 1/2, which is 1 over 2 square root of x, and then dx. Now we can write our integral into this form. So to produce the du, we need the dx over 2 square root of x. Okay, and then we have here same thing, square root of x quantity squared plus 1, and then 1 to 3. But because of the 2 here, okay, to make these two integrals equal, we have to multiply this integral by 2. Now we can already do substitution. Okay, we now have integral of this is equal to du. Okay, so this is equal to du over, you have there u squared plus 1. So now since our variable is already in terms of u, then we have to change the limits of integration in terms of u as well. So if x is equal to 1, u is equal to 1. And if x is equal to 3, u is equal to square root of 3. So we can now write our limits of integration as 1 to square root of 3. And this is equal to what? This is equal to 2 tangent inverse of u. So this is exactly the same thing as this one. And then evaluated from 1 to square root of 3, which is equal to 2 tangent inverse of square root of 3 minus 2 tangent inverse of 1. And what is a tangent inverse of square root of 3? So this means that the sine is equal to square root of 3 over 2. So that is pi over 3. So that is 2 times pi over 3, and then minus tangent inverse of 1. So that is pi over 4. And this is equal to 2 pi over 3 minus pi over 2, which is equal to, we have here 6, 4 pi minus 3 pi, which is equal to pi over 6. So therefore, this is the value of this definite integral. Next integral. Let's evaluate integral of dx over square root of e raised to 2x minus 1. So our integral contains a denominator, which is in the form square root of a square of a function. It's like u squared minus 1. And what is an integral formula that contains square root of u squared minus 1 in the denominator? We have the formula for the secant inverse. So our formula for secant inverse is integral of du over absolute value of u square root of u squared minus 1. This is equal to secant inverse of u and then plus c. So let's see whether we can use this integral formula. So if we're planning to use this formula, then our u must be equal to e to the x. So what if our u is equal to e to the x? So that this expression here becomes square root of u squared minus 1. If u is equal to e to the x, then our du is equal to e to the x dx, which can be written as u dx because u is equal to e to the x. Therefore, we have du over u is equal to dx. And we can now do the substitution and write our integral as our dx is du over u. And this radical can be written as square root of u squared and then minus 1. Now, keep in mind here that the absolute value of u, which is equal to absolute value of ex, e raised to x. E raised to x is a positive function. It is greater than 0 for any x. So therefore, this is just equal to e to the x, which is equal to u. So we can also write our integral into this form. Absolute value of u is square root of u squared minus 1, which looks exactly the same as this one. So therefore, the value of our integral is secant inverse of u and then plus c, which is equal to secant inverse of, writing back the u in terms of x, e to the x, and then plus c. Let's now move to our last problem. So let's evaluate integral of dx over square root of 3 minus 2x minus x squared. If we have this kind of integral where the denominator is square root of a quadratic function, where the coefficient of x squared is negative, we can usually evaluate this integral using the formula for sine inverse. But this requires completing the square. Let me show how to use this formula. Integral of du over square root of 1 minus u squared, which is equal to sine inverse of u and then plus c. So here, what we're going to do is we have to do completing the square in the radicand. So we have here dx over square root of, again, we have this one here, 3, and then minus, factor out the negative sign. And the remaining terms can be written as x squared plus 2x. And then now we do the completing the square here. We make this a perfect square trinomial. And to make it a perfect square trinomial, we just divide this coefficient by 2, and then we square it. So we get that 1 squared, which is 1. So we add 1 to this x squared plus 2x. Now, to make this integral equal to this original integral, so as you can see, we have here the minus 1. So we have to add a constant 1 as well. So we have here plus 1. So our integral can now be written as integral of dx over square root of 3 plus 1, you have there 3 plus 1, so that is equal to 4, and then minus this perfect square trinomial, which can be written as x plus 1 quantity squared. Now, since we're planning to use this formula, it should be in the form 1 minus a function, quantity squared. So to make this integrand in that form, so let's factor out the 4. So we can write this down as dx over the square root of, factor out the 4, and then we have here 1 minus x plus 1 quantity squared over 4, which can be written as x plus 1 over 2 quantity squared. And this is equal to integral of dx, square root of 4 is just equal to 2, so that is 2, and then square root of 1 minus the quantity x plus 1 over 2 quantity squared. So here, if we let u to be equal to x plus 1 over 2, then our du is just equal to 1/2 dx. So therefore, this expression here is just equal to our du, and this is equal to u. So we can write down our integral as integral of du over square root of 1 minus u squared, which is exactly the same thing as this expression here. Thus, this is just equal to sine inverse u and then plus c. And then we plug in the value of u, which is sine inverse of x plus 1 all over 2 plus c. To end this video, let me share a generalization of the three integral formulas that we discussed at the beginning of this video. We have integral of du over square root of a squared minus u squared is equal to sine inverse of u over a plus c. And if we know this formula, then we can easily evaluate our last integral, because as you can see from here, this is already in the form integral of du over a squared, where a is equal to 2, and then minus u squared, where u is equal to x plus 1. So its integral will be sine inverse of u over a, and our a is 2, and then plus c. And then the second integral is integral of du over a squared plus u squared equal to 1 over a, and then tangent inverse of u over a, and then plus c. And lastly, we have integral of du over absolute value of u, square root of u squared minus a squared, which is equal to 1 over a secant inverse of u over a plus c.